So here in 9.4 number 50, you have our next block of problems, and it's asking for the unit vector. The unit vector in the same direction. So a unit vector has a magnitude of 1. Now, this v that we're asked to look at, this negative 5i plus 12j, its magnitude is not going to be 1. So let's see what it is, because that'll be an important aspect. And so we just take the negative 5 and square it and the 12 and square it. Out of that, we quickly get a 25 and a 144. We recognize that that adds up to be 169, and we know that the square root of 169 is 13, so the magnitude isn't 1, it's 13. And so how do we get the unit vector that's headed in the same direction? Well, it's going to be the same direction if the y over x ratio is the same, because remember, it's tangent that determined what our reference angle was. And so all we have to do is proportionally scale it back and look at negative 5 over 13i plus 12 over 13j, just dividing the v by the 13. I've called it a different letter because it's, or a different letter, the u vector, because it's no longer the v vector. The v vector had a magnitude of 13, but the u vector is going in the same direction because its y over x relationship is still negative 12/5. However, its magnitude, if we look at it, its magnitude is 1, making it a unit vector. Look what would happen here. We'd have negative 5 over 13 squared plus 12 over 13 squared. So we would have u being, the magnitude of it being 25 over 169 plus 144 over 169, all under that square root. Well, if we add those up, we get 169 over 169, which we know is 1. And so the magnitude is 1. So the answer is this answer back here. What I did subsequent to that was just showing you that, hey, just by dividing out by the magnitude of v to all the components of v, we get a unit vector that's headed in the same direction.